Hey guys, so this is your Unit 7 Quiz 1 study guide. I'm going to go through all the problems. I highly encourage you guys to try them all on your own first, of course, and just use the video for those ones that you get stuck on. All right, so the first thing we're going to talk about is how to simplify. So these are both monomials. When you have monomials, you just reduce the fraction like you normally would. 18 over 9 reduces to 2 over 1, and m to the third over m squared. Basically, you subtract your exponents. 3 minus 2 is 1, and you're going to put that m to the first power on the top because that's where the bigger one was to end with. You don't really need to write the 1 if it's a power, and you also don't need a 1 on the bottom. And so our answer would be C. All right, let's go ahead and take a look at another one here. So when you're dealing with polynomials, which is what this one is, you have to factor them first. So on the top, the first thing you're going to do is you're going to take out a 2 out of there. You always look for your GCF first, right? So if I divide all those by 2, I'd be left with this. The bottom does not have a GCF, so I'm just going to leave that one alone. But we need to see if these can factor using the box method, and they will, because if they didn't factor, we wouldn't be able to do anything. So let's go ahead and factor these. Put n squared here and negative 6 here. So we're looking for two things that multiply to make n squared. That would be n and n. And then we need two things that multiply to make negative 6. That would be 3 and 2. Now one of them needs to be negative, but let's fill in our box to see which one it is. We know that these two have to add up to make the middle. So I need a negative 1n, which means it's the 3 that would be negative. So there's that. So the top of my fraction is now 2, and then n plus 2, and n minus 3 from there. Now we need to do the box here on the bottom as well. So we have 2n squared and 27. That would make 2n squared. What makes 27? Well, 9 and 3 does. So let's see if I can get this to work on my first try. We have 6n here and 9n. We need 15. That would work if they were both negative. And so we have 2n minus 9 and n minus 3. So after you factor it, you cancel out the factors they have in common, and our answer would be B. So factor and cancel, that's the idea there. All right, let's do another one here. Multiplication, it's actually just more of the same thing. It's just factor and cancel. So we need to begin by looking for what can be factored. The only thing that can be factored up here is this thing, using the box method. So we have 6v squared goes here and 35 goes here. Now, just to clue you guys into something here, we know it's one of our factors has to be one of these when we factor this top, because if they didn't, then nothing would reduce out. So when we're doing that, keep that in mind. So what makes 6v squared? How about 2v and 3v? What makes 35? How about 7 and 5? Notice the 2v and 7. 2v7, 3v5, 3v5. All right. Let's see if this actually works, though. 2v times 5 is 10v. 7 times 3 is 21v. And sure enough, these add up to make the middle, 31. So we've got our result here. So I'm going to go ahead and drop that out. And in its place, I'm going to write the factors. We have 2v plus 7 and 3v plus 5. And basically, this 2v plus 7 takes that one. This 3v plus 5 takes that one. Even though they're in different fractions, that's okay, because when you're multiplying, it just makes it one giant fraction anyway. And all you're left with then is this guy, so the answer would be D. Okay, let's go ahead and move on to another one. Division. division is going to be a lot like the last problem, but with one extra step in the beginning. The extra step in the beginning is to keep the first fraction the same, change the division to multiplication, and flip the second fraction over. After that, you just do it exactly the way we did the last problem. However, I mean, we could factor this, and we could factor this, but do you notice something? They're already the same. So even if I went through the trouble to factor it, they're just going to completely cancel each other out anyway. So let's just go ahead and do that and save ourselves some time. And nothing here cancels. So we're done with that, and you would get D as your answer. All right. Next, we'll talk about adding. Now, when you're adding two rational expressions, and they have to have the same denominator. Now, in this case, they do. So we're good. All I need to do is combine the m's and the -6 with the 2. So m plus m is 2m. -6 and 2 is -4. And my bottom is this. Now, let's see. Even though we did that right, I'm wondering if we'll find that answer here. Yep, it's there. Okay, so we're done. Now, just know that sometimes you are required to simplify these, like factor and reduce. But my advice is after you add them together, just check to see if your answer is there at that point, because a lot of times you don't need to reduce these. They just turn out where they're not reducible a lot of the time, as I've mentioned in class quite a bit. All right, so here's an example of two rational expressions that don't have a common denominator. I'm going to show you guys two kinds of these. One where it's just a monomial, that's this one. My denominators are both monomials. The next example will have binomials or something else. So monomials are the easier one. To get these denominators to be the same, we just need to multiply this side by an a, right? Now the bottoms are the same. Sometimes you need to multiply both parts, but in this case I just needed to do that one. And so now that they're the same, we just go ahead and put the tops together into one fraction over that common denominator of 2a, and we're good to go. Let's see, which one of these is the answer then? I'm not seeing it. Am I blind? Oh, you know what? We can go a little bit further. I see what we can do here. We need to reduce this. And I said a lot of times they don't get reduced. I didn't see my answer here, so I got a little bit confused. But look on the top here. What do these have in common? They both have an a, right? So I can take an a out of there. And now that I've done that, I can cross off the a's. And so it's 5b and -6 over 2. They've got it in a different order, but that doesn't matter. The 6 is still negative and the 5b is still positive. So there you have it. All right. Let's go ahead and take a look at another one. So now in this case, we have a monomial on the left and a binomial on the right. A lot of times when you're doing these, you want to start by factoring, but neither one of those are factorable, so we don't have to worry about that in this case. So for this one, what I'm going to do is I need to multiply this side by 6b, and whatever you do to the bottom, you also need to do to the top. And over here, I don't like how I wrote that 6, looks like a b. All right, over here we need to multiply both sides by b minus 1. Okay. Now on the bottom, we're not going to actually multiply anything together, but on the top we need to. So let's distribute that 6 first of all. And then plus 3b times 6b is going to be 18b squared. Now let's stop and see if that answer is anywhere over here. I'm not seeing it, which means that even though we've combined them, it can probably be reduced. So let's see. Now the bottom doesn't need to be factored. That's why I prefer to not multiply the bottoms together, because it leaves it factored, which helps you reduce later if you need to. But the top can be factored. First of all, there's a GCF, so let's start there. What do all three of these have in common? They can all be divided by 6, right? And that's good news because now I can cross off the 6. Now let's see if our answer's down there. I see it. It's right there, part C. I find it funny that the order of the terms matches too. I would have thought they would have put this one first and then the B and then the minus one, but they didn't. Anyway, there it is. Let's move along. So sometimes you do need to reduce. Just check your answer options there and see if it's there. If it's not, then you probably need to reduce. So I think that's all that's going to be on your guys' quiz is reducing, multiplying, dividing, and then adding and subtracting rational expressions. Now, this past Monday, we talked about some other examples a little more advanced. These are more like the ones that we left off on Thursday. But there you guys have it. So we'll see you guys on Wednesday.